Okay, so this is the beginning of Unit 10, Acids, Bases, and Salts. In this unit, we will obviously discuss acids, bases, and salts. And if you remember from previous units, salts are any ionic compound. So the first page here talks about a warm-up video. This is a video from Modern Marvels. So if you want to watch the Modern Marvels video, just go to Modern Marvels, search for acids, and you can watch the video that everyone saw. All right, so the first thing you need to know is the acids definition. Now, acids were defined first by this gentleman named Arrhenius, and that's his last name. First name is not important. It's not important when it was, but the definition is this is the most narrow version of an acid definition. And there it is. It talks about a substance that dissolves in water, is producing the only positive ion being a hydrogen ion. The hydrogen ion is also called the hydronium ion. When the hydrogen ion combines with the water molecule, it attaches itself. And when it attaches itself, it makes an H3O plus ion. Those are Arrhenius acids. Arrhenius acids can all be found on Table K. Table K in the reference tables, they show you the common acids that are used on the Regents exam. And they go generally from the strength of the highest strength at the top to the lowest strength at the bottom, weakest acids. So a strong acid would be considered hydrochloric acid. That is the acid that you find in stomach acid. The next one, so that's a strong acid right here, strong acid. We also have a strong acid in nitric acid. Nitric acid is an especially strong acid, as well as sulfuric acid. Now you'll notice there's a couple acids in between there, the nitrous and the sulfurous. They are weaker acids than those big three. The big three, hydrochloric, nitric, and sulfuric, those are the ones you want to recognize as a strong acid. At the bottom of the table, you have your weak acids. A weak acid is an acid that does not dissociate entirely. A strong acid will dissociate, a weak acid will not dissociate. That we will talk more about later, but understand that there are at the bottom two of them. The first weak acid, or the weakest acid, is this one here called ethanoic or acetic acid. That is an organic acid. And you know it's an organic acid because you have carbons and hydrogens in front of this group right here, the COOH. COOH is the indication that you have an organic acid. The one above that is carbonic acid. And carbonic acid is the acid that's in soda. When carbon dioxide dissolves in water, you get carbonic acid. And that's what that is. It's just carbon dioxide dissolved in water. When your soda goes flat, all of a sudden it tastes sweeter. That's because an acid has a sour taste, and as that sour taste is diminished, as the carbon dioxide evaporates out of the solution, the sour taste leaves behind the sweet taste, and there you end up with a sweeter tasting soda, in flat soda. Way back when we talked about different types of compounds, and in the different types of compounds, you were told to look at the first element. The first element tells you what kind of a compound you have. Now, in this case, acids are all nonmetals. We have all nonmetals. And so it's a covalently bonded compound called a molecule, but they're special ones. They're special because hydrogen is different than other molecules, than other atoms in the molecule thing. Acids generally start with a hydrogen. They do that because hydrogen is different. Hydrogen is similar to the group 1 metals in so much as it acts like a positive ion, but it's still a nonmetal. So that's why it's shown on the periodic table lifted up above away from the other elements in group 1. It's not a metal, but it has tendencies to act like a group 1 metal. So when you add, when you start talking about when you start talking about the idea of doing nomenclature, naming an acid or coming up with the formula of an acid, that has its own specific rules. This is not part of the New York State Regents curriculum, but I thought I'd include it for you here. This is found in this packet that I gave you a while back. This breaks it down right here, talks about the first element. If the first element is a hydrogen, you know you have an acid for the most part. There's three specific instances when we're talking about acids. The first instance is if the anion is monatomic. If the anion is monatomic, as in HCl, you have a monatomic anion acid. The name is going to be hydro. The anion root, which would be, for example, if we had HCl, you would call that hydrogen chloride. So in this case, what you do is you take off the hydrogen, and in its place, you're going to put the word hydro, or the prefix hydro. Now, because you have a monatomic anion, the root of this anion for chloride is chlor. So you're going to keep the chlor, but you're going to remove the ide. Now that you have removed the suffix ide, you're going to tag on the suffix ic, and then the name acid. And this would be named hydrochloric acid. The next instance is if you have something that is have a polyatomic ion. Now, if you have a polyatomic ion and it ends in 8, it's a similar kind of situation. In this case, you would take the anion root, take off the hydrogen, take off the ending, the suffix 8, and put on ic. So, for example, if we had hydrogen nitrate, its formula HNO3. So again, the first thing we will do is remove the word hydrogen, because this one does not have a hydrogen out front. There is no hydro either. You just remove the word hydrogen. Now that hydrogen is gone, what I'm going to do is change the suffix of this word from nitrate to ic, to nitric acid. So HNO3 is just simply nitric acid. The last scenario is if our polyatomic ion ends in ite, ITE. In this case, something like hydrogen nitrite, whose formula is HNO2. So HNO2, hydrogen nitrite, we're going to do a similar kind of thing. First thing we do is remove the hydrogen. Now we have nitrite. So we now remove the suffix ite and add the suffix us with the word acid. So HNO2, hydrogen nitrite, becomes nitrous acid. And this is the other acid that is found on this table here, table K, HNO2, nitrous acid. Nitrous acid was originally hydrogen nitrite. When you put the nomenclature for acids on it, it becomes nitrous acid. So that's the acid nomenclature, which is nice to know, but you don't necessarily need to know. This brings up the Arrhenius base. And the Arrhenius base, that was the other thing he defined. Arrhenius defined bases as any substance that produce the hydroxide, the OH minus ion, as the only negative ion in an aqueous solution. There's lots of these, but actually there's not many of these. They are a metal hydroxide. The nice thing about these is naming them is just the same as an ionic compound nomenclature. So NaOH, KOH, CaOH, those are all simply a metal with a hydroxide ion, just like you would find in an ionic nomenclature. Sodium hydroxide, potassium hydroxide, calcium hydroxide. Table L lists your common strong bases at the top and weak bases at the bottom. Now the one at the bottom does not have a hydroxide. That is an NH3. That's a different kind of base as defined by another definition other than Arrhenius. And we will talk more about that later. But Arrhenius was the first person that you need to understand. And that's the only definition that you need to know by name. Arrhenius bases are things that produce hydroxide ions as the only negative ion in solution. And so that ends the lesson on Arrhenius acids, Arrhenius bases. If you have questions, look in your review book under this topic. You'll find it there.